Okay, welcome back, my 8th graders. I know that you guys are all culminating this semester and you're really looking forward to go ahead and getting the, hitting the ground running here. So we've been studying 8th grade functions that are linear and proportional. So you guys are used to seeing these tables like this. We go ahead and we put our x values, which are also called input values, which are also called the domain values. We have to usually take a function and we have to find out whether that function is linear, and if that function is linear, we have to go ahead and tell whether it's proportional or non-proportional. Then we have to go ahead and tell it whether we found out the x values, okay, called the f of x values, the function values. These f of x values are also called the y values, the range values, or the output values. And then we have to list our coordinates right here. So let's see how we've been doing this in class. Well, we take our x value and we substitute in -2 here. And we use this x value here and we substitute in 0 here. And we take this x value and we substitute in 2. What we have to do is we have to multiply this by 3. So I'm going to multiply all of these x values by 3. So I'm taking 3 and I'm multiplying it by -2 for the x value. I'm taking 3 and I'm multiplying it by 0 for the x value. And I'm taking 3 and I'm multiplying it by 2 for the x value. Then I need to subtract this from 5. Well, if I do the math correctly, I can find out that this is 5 minus -6. This is going to be 5 minus 0. See, 3 times -2 is -6. 3 times 0 is 0. And what do you think this one's going to be? Well, you're probably right. This one's going to be 5 minus 6. So now we can find out what our y values, our range, our output values are. Well, this value here is going to say this y is equal to 5 minus -6. Well, that's the same as putting 5 plus 6. Because when you subtract the negative, it's like adding a positive. That means this value says y is equal to 11. This one's pretty easy. Y is equal to 5, because 5 minus 0 is 5. And this one's pretty easy too. But don't make the mistake of putting 1. See, 5 minus 6 is actually -1. Now what we can do is we can put our coordinates. This input value is x, and this output value is our function of x. So we're going to put -2, because that was our input domain. And we're going to put comma 11, because that was our output value. This one here is going to be 0 for their input value, and we're going to put 5 for our output value. And for our last point, we're going to put 2 for our input value and -1 for our output value. These are our 3 points. Now we have to list whether or not this function is linear or proportional. Well, let's take a look at our function. This function, can we write this function in slope-intercept form? Well, let's see here. I could write this as y equals -5x plus 3. Is that right, guys? Oh, you guys caught me. Yeah, obviously this would not be correct. See, I can't just go ahead and mix the numbers around. I'm looking for the numbers that's the slope. And this -5 is actually not the slope. The number that the slope is the number directly in front of our input x. So this is actually going to be y is equal to -3x. And then I'm going to add a +5. So our input values are going to be x. And the number in front of that is our slope. So you can't just switch numbers around. You're always looking for the slope, which is right in front of your input value x. So can we write this as a slope-intercept equation? Yes, we can. If we look at this, let's try to use this point right here. See, this point is where x equals 0 and y equals 5. If this linear function, and this is a linear function, because we're writing it as a slope-intercept equation, is this linear function passing through 0, 0, which is the origin? No, it's not. When x is 0, y is 5, and it's supposed to pass through the origin. That means that this must be non-proportional. It's non-proportional because it doesn't go through the origin. And that's what we've been studying in class. So hopefully these notes are going to help you. This table, you're going to see a lot more of it this semester. And we know that it's linear because it's going to create a straight line. And we know it's non-proportional because we know it doesn't go through the origin. That means when x is 0, y, our output was not 0, it was 5. Well, I'll catch you guys next week on our next video.